Hi, my name is Jesenia Rodríguez, and I am going to talk to you about the solution of the exercise. The exercise says the geotechnical consultancy in Guayaquil has a demanding project, which is the construction of a five-story building. According to the structural engineer, the highest recorded load of one of the columns is 5,000 kilonewtons. It is requested to design a pile that can support this load through both shaft and tip capacity. But the length and the cross-sectional dimension should be defined by you. Design a circular and a square section. You may apply any of the methods used in class or from the guide text. Okay. Now, to begin the design, we must understand the soil conditions. It has three layers. The first layer is gravel, 5 meters high, and layers 2 and 3 are clay and 10 meters high respectively. Then, we have the assumption for the circular section. I assume a diameter of 2.6 meters and a length of 17 meters. As the first stratum is considered a sand, then it will be used the following equation to calculate the unit resistance per shaft. Now, for the first layer, we will use the Bryan method, which consists of multiplying the pressure by 0.224 and by the number of flows and 16 raised to the 0.29 power. The pressure and the number of flows are data that the exercise gives us. Then we replace the values and we get a result of 49.13. Finally, we calculate the load per shaft, which is equal to the perimeter times the length of the stratum and by the Fs, giving us a result of 2006 kilonewtons. For layers 2 and 3, which are clays, we will use the alpha or IP87 method, in which for ease of calculation we have made a table with all its parameters and respective values to find the load per shaft. The values of alpha and C are calculated with the formulas that are there, and for the effective vertical stress it is calculated. For stratum 2, it is equal to the height of the first stratum by its density plus the height of stratum 2 half by its density minus the density of water, and for stratum 3, it is equal to the height of the first layer by the density plus the height of layer 2 by its density minus that of water plus the height of layer 3 half by its density minus that of water, giving us a result the load per shaft for layers 2 and 3 equal to 1,249 and 5,362.54 respectively. The two loads added equal to 6,611. Then, for the total load per shaft, we add the load per shaft of the sand plus the load of the next two stratum, giving us the same as 8,618 kilonewtons. For layers, now to calculate the tip load in clays, we will use the Meyerhof method, which is equal to 9 times SU times the area, giving us a result of 6,853. And to finalize the calculation of the circular section, we must verify that our proposed dimensions comply with the safety factor. It tells us that Q at is equal Q ult divided by a safety factor, which in this case we set to 3. To find well Q ult, we add the total load per shaft plus the tip load and then divide that value by the safety factor, giving us a result of 5,150, which is greater than the load indicated in this exercise of 5,000. This means that with a diameter of 2.6 and length of 70 meters, it meets the requirements of the safety factor for the circular section. For the square section, assume the same dimension that the circular section and the length too. The section is B per B is equal 2.6 per 2.6. The length is the same, 17 meters, and the same method for circular section to calculate the unit resistance per shaft. For that is the Bryan method, and the result is 49.13 kilopascales, and the load per shaft is 205,054.76 kilonewtons. For the layer 2 and 3 for clay stratum, we will use the same method, alpha method or API, to calculate the values of the vertical effective, and the C and the alpha will be used the same formulas and processes that were used in the circular section, the same. And the load per shaft total is equal to 10,970.96 kilonewtons. For the deep load capacity increase, we will use the same method for the circular section, Meyerhof method. The deep load is equal to 807,000.12 kilonewtons, and the Q yield is equal to Q per shaft more Q per Q tip. Deep load is equal to 90,671.08 kilonewtons, and the Q admissible is equal to QU divided for 3 is equal to 605,057.03 kilonewtons. The Q admissible is more than the load is equal to 500 kilonewtons, 5,000 kilonewtons, and satisfy the criteria and say the square pile with 2.6 diameter and 17 length meets the requirement of safety factor. Thank you.